So I've got a couple of examples for you to have a crack at here involving special cases with integration by parts. 2 questions. I'm going to show you them. I want you to pause the video, have a crack at them, and then come back and check your answer with the working I'm going to present to you. So here you go. So like I said, just 2 questions. First one is I want the integral of e to the x sine x dx. And the second one, I want the integral from 0 to e of ln of x to the power of 4 dx. So pause the video and have a go at those. So the first one was integral of e to the x sine x dx. Now again, the general steps don't change from our integration by parts. The one thing you should notice though is that e to the x and sine x are both functions that no matter how many times you take their derivative will not disappear. So this should be an indication that we're going to be using this technique where we're going to have to get the same integral on both sides and treat it like an algebraic equation we would normally have covered in S1 or 2. Now we start with the same first step that we've always done when it comes to integration by parts, assigning u and v dashed to then be able to work through. Now in this case, what I'm going to do is I'm going to set u equal to e to the x and my v dashed equal to sine x. Point to make here is that it doesn't matter which way around I do this for this example, purely because it's going to cancel out, all the negatives will still work their way out, it's just personal preference. U dashed is equal to e to the x here, and then v is equal to negative cos x in this scenario, and now I can plug it all together using the formula. So I get the integral of e to the x sine x dx equals my u times v. That'll give me negative e to the x cos x. I'm then going to take away my integral of vu dashed. Well, this is a minus here, so that's then going to turn it into plus the integral of e to the x cos x dx. What I now have to do is I now have to do this integral here. Now, one thing to remember is stick with the way you've assigned them in this. So I've assigned my u to the exponential function here. So in the second one, I'm going to stick and assign u to be the exponential function again. I'm also going to stick by making my v dashed be the trig function. However, in this case, the trig function is the cos x. So here, my v dashed is equal to cos x, which means my v is equal to sine x. So this integral here can be written as u times v, so e to the x sine x. Take away the integral of v times u dashed, so e to the x sine x dx. So what I'm now going to do is plug all this back together in one integral and write it as the integral of e to the x sine x dx equals, well, this first part here, minus e to the x cos x. Then it's plus all of this integral here. So it's then going to be plus e to the x sine x. It's then going to be minus the integral of e to the x sine x dx. Lo and behold, this and this are both the same. Stick them together on the one side and then let's solve it from there. So if I shift this across here, I get 2 times the integral of e to the x sine x dx equals e to the x bracket sine x minus cos x plus c. All I've done here, taken e to the x out as a common factor and put it so it's sine minus cos, so I don't start with a negative. Then divide both sides by 2 and I can write down that the integral of e to the x sine x dx is equal to e over 2 bracket sine x minus cos x plus Old Faithful c, the constant of integration. So there you go, solving that one there. Second question, was the integral from 0 to e of ln x to the power of 4 dx. Now, just because I've got limits doesn't mean any of my steps change. I still start by assigning the u and the v dashed and working it through from there. Now, because it's an ln here, what I'm going to do is treat it as the integral from 0 to e of 1 times the ln of x to the power of 4 dx. Because what that then means is I will assign v dashed to be equal to 1, which means my v equals x, and I'll assign my u to be equal to ln x to the power of 4, which means that my u dashed is equal to 1 over x to the power of 4 times 4x cubed, which will then give me 4 over x. So now if I plug it all together, what that then is going to be is it's going to be vu, so x times ln of x to the power of 4, and that's within my limits of 0 to e, take away the integral of 4 over x dx times x. Now the x and the x there cancel out, so that second part there just becomes the integral of 4 dx, which is quite nice, in that it's just 4x. Now the limits apply to every stage of this, so I can't forget to apply the limits to this integral as well. Once I've done that, stick it all in the same limit section. I'll have x ln of x to the power of 4 minus 4x. And that's between 0 and e. So now all I have to do is simplify this down. Plug in my limits, simplify it down, and see what I get. So starting at the upper limit, I get e times ln of e to the power of 4, take away 4e, then take away 0 times ln of e of 0 to the power of 4, take away 4 times 0. Well, this whole bracket here is just going to disappear and be equal to 0. This bracket here, well, if I bring the power of 4 down, I'll have 4e times ln of e, and we know ln of e is just equal to 1. So I'll get 4e here, take away 4e, funnily enough, that's equal to 0. They all cancel out. So there you go. Using the limits is no different. Same technique, same steps. You just have to remember to apply it at the appropriate time and substitute in our limits.